Linear Algebra student, this video is for chapter 2.1 part 3. The last topic is about power of a matrix. That means multiply matrix multiple times, and also a new term or a new notation called transpose of a matrix. First, power of a matrix means repeat multiplication of the same matrix a certain time. So a to the power k means a k times. So it's just like numbers. But the only thing that is different from numbers is, remember, when we multiply with a vector, if it is multiplying a vectors, multiply a vector x, that is a what is it called? A linear transformation, right? So if I applied it a lot of times, so that means after I multiply it, it become another vector, and I multiply it multiple times, it means you multiply a repeatedly by a k times. So the only difference is akx is means left multiplying x by a k times. So that means you do ax, and then you do ax, and then you do left multiplying a times. So that is called akx. So this is used later on in chapter 4. It's the notation. And so if you do a power 0, so in number is 1, right? So a to the 0 is an identity matrix, so it becomes x itself, the original vector. Transpose of matrix is kind of, I think, just like the name before, horizontal become vertical, vertical become horizontal. So you form the column by the row. So for example, matrix A is 2, 3, -4, 0, 1, -5. That's like rows, right? A transpose will make 2, 3 become the column. Okay. You look at the row and you change it into column. So that is a new matrix called A transpose. So this matrix is 3 times 2, right? The dimension is 3 row, 2 column. After you transpose it, it's 2 rows, 3 columns. So just the row and columns number switch. So these are some properties of a transpose of a matrix. So A transpose and then transpose back will move it back to A or change it back to A. If you add together two matrices and transpose them, it's as if you transpose them individually. If you multiply a scalar to a transpose matrix, it's as if you multiply the scalar to the transpose of it. This one is the difficult one. If you multiply AB and then transpose it, is not the same as you multiply A transpose B transpose, but actually B transpose A transpose. So you actually switch position. Okay, so this one is a kind of a difficult one. We'll show it. We'll show that this would work. Let's say we have a 2 by 2 by 2 matrix, and I'm going to do AB transpose. That means I'm going to multiply them first. So what is AB? AB would equal to a row times column. So 2 times 5 plus 2 times 1, 13. And then row times column, so be -4 minus 9. -4, yeah, no, 4 minus 9, right? -13. And then row times column, -20 plus 2, -18. Rows times column, +8 minus 6, -14. Oh no, 8 minus 8, +8 minus 6 is -2. No, +8 minus 6 is +2. It's like that. Okay, if I transpose it, after I multiply it, I'm going to transpose it. So I would write the row as column, 13, -13, -18, 2. So let's do A transpose. Let's write A transpose here. Save some space. So that would be 2, 3, negative 4, 2, right? B transpose is 5, negative 2, 1, negative 3. So let's try A transpose, B transpose first. So that would equal to these multiplied by these. So that would be 2 times 5 plus 8. So that's 18. So you can obviously see that it's not like AB transpose. The first row multiplied by the first column, it will be 2 plus 12, 14. The second row multiplied by the first column, 15 minus 4, 11. Second row minus second times second column, so be 3 minus 6. 3 minus 6 is negative 3. So obviously these two are not the same. But what about B transpose, A transpose? So let's do B transpose, A transpose. So I'm going to copy it down, switch the position. Actually write B first, and then 2, 3, negative 4, 2. Okay, so multiply row and column. So it's 10 and 3, 13. Row and column, negative 20 plus 2, negative 18. Right, so this is the same. Row and column, negative 4 minus 9, negative 13. Row, columns, plus 8 minus 6, 2. So you can see that AB or transpose is the same as B transpose, A transpose. So this is one example, but it works in general. Let's do some multiplication using using vectors. So vector, you can strictly speaking, is actually a column matrix, right? So let's, but how can I multiply with anything if it's just one, like there's 2 row but no column? So every row is just one number, right? Every row is one number. So you can see that you cannot multiply U and V together because you have one row, but there's multiple columns for a column vector. So C and D would not work. Does not work because U is you had a one column, but this has 2 row, right? Not compatible. And U transpose has will become 4, negative 3. You have 2 column, but V transpose would have only one row, right? X, Y. You can't do that. But A and B would work, right? U transpose, so let's do U transpose. If I transpose it, it'll become 4, negative 3. And I can multiply X, Y. Why? Because I have 2 column and 2 row. And then the answer would just be one number. Why? Because if I have some row, 1 column, and that's just one number. 4x minus 3y is a vector with 1 entries. 1 row, 1 column. What about I do V transpose first? So V transpose will become xy, and then multiply U, which is 4, negative 3. So it becomes, again, 1 row, 1 column, right? So 4x minus 3y also. You can see that that's the same. The last example is if A and B are 2, 3 by 3 matrix. So we can write the entry out A11, A12, A13, A21, A22, A23, A31, A32, A33. Okay, so that's A. And B is the first column is all 0, 0, 0, 0. And then I have B11, B12, no, B1, no, this is not B11, this is B12, B13, right? B22, B23, B32, B33. Now, these are all variables. If I'm to multiply them, what would happen? The first row with the first column would always be 0, right? If I do this and multiply the column, it's also 0 because every single entry is 0. But these will not be, right? So that I have other things. This would be other things. But I know 100% sure that the first row, a first column of AB is 0. The other one would not be guaranteed because I would have the same row but multiplied by the column. The column could be 0, could be not 0, but it's just given that the first column is 0, then the answer would have the first column 0 also. So these are some of the properties of matrix multiplication and also transpose.